Good morning, everyone. My name is Victor Madrigal, and I work as a research associate at the Institute of Transportation Systems by the DLR here in Berlin. And I will present you a work package I supported in the i4Port project called Optimization of Ports Landside Traffic in SUMO. So let me get started. Okay, here's the content of my presentation. I will start with a brief introduction, describe the motivation, explain what truck appointment systems are, talk about the optimization approach, following by the description of the simulation scenario, and then its implementation in SUMO. And to finish with some simulation results and some analysis. Okay, as an introduction, I will briefly describe what the i4Port project is about. One of the main goals of the i4Port project was to explore the methods that can ensure the optimized and efficiency of the sea transport processes into an intermodal hub. So this with the help of technological techniques. So in order to achieve this, there was a participation of the Institute of Flight Guidance, the Institute of Communication and Navigation, and the Institute of Transportation Systems to bring all together our competences in the corresponding fields. And in my case, I supported the road optimization side. So yeah, altogether to explore new methods, how to optimize this handling of goods between the sea and the land transport systems in a more efficient way, and also to be able to simulate it in a virtual machine in SUMO in this case. So yeah, as motivation, it's important to mention how fast is the change in the volume of goods that are being transported by sea, especially by containers. And over the past years, these trends continue to rise together with the competition also among the shipping companies, and especially during this pandemic transition. So we can see some numbers from the United Nations Conference on Trade and Development from the 2019 annual report. Currently, the globalization of the economy and the trade of materials have been increasing the volume of transport. Here we can see some numbers. And here in 2019, it's all-time record, but 11 billion tons. And also in the past 20 years alone, the sea transport has increased 3.2% annually. So this is also reflected on the transport capacity of the global fleet in 4.9%. So all these increases also related to the increase on the average size of the ship vessels. So we can see an increase up to 5% for the past 5 years and 83% in the previous decade. So having all these challenges obviously creates some conflicts in the port terminals, and especially on the land side of the port. One of the main consequences is truck congestion, and the reason for truck congestion between the gate and the yard is mainly because this uncertainty of the truck and container ship arrival times. Okay, so what is the basic strategy? Truck appointment systems. It's a basic strategy to mitigate congestion between the gates and the operational yard. But usually the current approach is to expand the yard and the gate spaces. So basically changes in the infrastructure. But however, these changes require a lot of time and investment, and sometimes it cannot be applied as space expansion in a small area. So therefore, it's necessary to solve truck congestion with new technological methods that can benefit both the stakeholders from the port terminal and the truck carriers, and also to reduce the emissions from the trucks. So the implementation of a truck appointment system is a very well-known solution to distribute trucks evenly through the day. And one big advantage is to reduce this operational cost for the terminals, truck carriers, by reducing queue lengths at the parking area and at the gates. So if a terminal does not influence these truck arrivals and does not receive this advanced information, sometimes the resources do not match the demand, and we have these peaks on the congestion, and it's a waste of resources for both ends. So in order to smooth this arrival, the terminal assigns time slot time windows, usually 1 to 2 hours, to these drayage operations. And this lot assignation corresponds to the number of trucks that can be managed in this time window. So it should be assigned, of course, in a way that terminal resources are used as efficiently as possible without creating congestion. Also, in addition to how to smooth truck arrivals, depending on the design of the task system, it can provide information about the truck arrival times and also the ship and container position. So if we use this data to the terminal processes, we can adapt the arrival times and also the departure of the truck. So in this way, we know the capabilities of the intelligent transportation system techniques, such as vehicle communication technologies. They can use this type of information to improve the current methods. Okay, my proposed optimization. That being said, Tracy provides us some useful functions, and which can interact and retrieve information of such processes in a simulation scenario. So such information can be the container ID, truck and ship positions, and travel speed. So we can use these inputs to optimize the process of collection and delivery into our terminal scenario. So this, we can see the flow chart is a little bit simple, how we can distribute the time windows in a more efficient way by sharing this information in real time. So yeah, we can share, we can see this. Can you see this? Oh, okay. Sorry, my window was black. 1 second. So we can see this flow chart. So each truck carrier receives a precise window that can help reduce the arrival times to a better route planning as in a multi-agent approach. So we have the port terminal agent that decides which time window will be accessible to the truck agent, and is the decision process for the truck agent to accept or deny this assignation in a more real-time process. We have this scenario. The starting point for this was the determination of the case study. And to simulate truck traffic on a port, the simulation model of the Scandinavian port, Lübeck port, was created. This port has a good hinterland connection with several intermodal transport, such as truck and container transport, so it's suitable to our proposal approach. The scenario consists on a 7-hour period of congested scenario, including 10 ships, 1,500 containers, 1,500 trucks as well. And the container demand into the port is carried by the trucks and ships, as well as the collection process. The scenario of the landside port terminal includes the operational yard, which the drayage operation takes places, and as well for the three piers here on the scenario for the ship demand. So also the truck carriers consist of 3 different access routes described for each color. And it's divided on 50% delivery operations and 50% collection operation for our test case. Well, as many other colleagues has already explained how the implementation in SUMO works, the first step was to establish a SUMO network created by the OSM wizard tool, as well for the vehicle types, the demand, and the route definition. And all the necessary changes were carried on onto NetEdit. So the next step was to couple the simulation with the Python script via Tracy. And within this Python script, we developed this optimization model, which is able to retrieve position of the containers and the ship and truck also out of the simulation, and then apply this schedule policy between the port terminal and the truck carriers. Everything is carried by sharing real-time information about the vessel arrival and also the container status. I don't know if you can see it. Is it a video? Is it running? Okay. Here's a video how the optimization approach of the task operates. Here we can observe the port is divided in 3 section views. The first section from left to right is the parking area where congestion occurs. And the second view is the general view of the port. And the final view is the section where the 3 access tiers and part of the operational yard. So we can see the processes. In the scenario, the port terminal is currently receiving information from the ships, from the ship vessels. And whenever a ship vessel is in the range of detection, this can be hours in advance or days in reality. But then the schedule policy of the port terminal starts to send message to each truck carrier. So with this proposed time window assignation, so they can accept it or deny it whenever it's available. So here, as I explained it, each color is a different truck carrier, so they can adjust their arrival times accordingly to the received information. Yeah, and the simple goal was to improve a simple task where large fixed time windows are deployed without the certainty of the operational times. And there's a second video. I will jump to analysis and results when we can see both scenarios. I don't know if it's running. I don't think so, right?
No, it's running.
Okay. So it's a crucial comparison about the two analyzed approaches. Here's the most congested operational time segment of the scenario. And on the left side, we can see the optimized task. And the second one is a traditional task where large time windows are assigned. So on the scenario on the left, the port terminal has already assigned advanced time windows in which trucks have already planned their routes and also adjust their departure times accordingly. On the other hand, there's the same scenario with fixed time windows in which trucks are assigned without this precise information about the containers. And we can see some truck congestion at the parking areas. Well, it's repeating, but you cannot see it right now. Let me see if it's again the video. Okay, I will jump. So yeah, I will jump to the analysis and result that we have. It was a simple optimization approach, and which integrate these vehicle communication technologies into a simulation environment to optimize a task approach. And here we chose these parameters to be evaluated during the simulation. And here we can observe some differences. The main gain was in waiting times and the travel times. As already mentioned, truck can adjust the departure times in advance to avoid these peak hours at the terminal, and also as well for the speed, trip duration, and stop trucks. Also improve this fact of the level of occupancy of the parking areas are reduced, and also for the queue lengths at the gates. So as conclusion, that was a description of the brief work package I supported within the i4Port project. That was the landside optimization of a port approach using SUMO. And yeah, let me know if you have any questions. That is the end of my presentation. And if you want to know about the i4Port project, I can share the following links. And regarding ships and container generation in a SUMO network, there is a port tutorial on the SUMO wiki that was developed by our colleague Melanie Weber. So she's part of the SUMO team. So feel free to visit the website or send me an email if you have any more questions.